Alright, this video is an explanation of how to install a pool pump. We're going to do much more than how to install a pool pump. We're going to talk about if it's even the pump in the first place and how to tell. Excuse me, we're going to talk about how to select the correct pump that you need, and then of course how to do the installation, how to do the programming, how to protect the plumbing after it's installed. So that's what this guide is going to go over. It is an in-depth guide, so it's a pro can do a pump replacement in 1 to 4 hours, depending on the complexity. And a novice sometimes can take up to 8 hours. It will be very helpful if you have some basic knowledge of electricity as well as plumbing, but we'll go over as much as we can. And then, of course, feel free to reach out if you have questions on it or if there's a way we can make this guide better. I'm happy to chat with you a little bit about it. Why am I making this guide? I'm a pool pro. I make money off of repairs, installations. That's how I make my living and feed my family. So I'm probably helping way more people install their systems on their own, but as I go through this guide, it's going to demonstrate that I'm very capable, and if you so desire to choose me to select me to install your pump for you, I'd be delighted to do that and make sure you have a very good pump set up for you. So jumping into it, first question, is it a pump related issue? So I've seen this a couple times. I get a call, I'll go out to the job, and there's a brand new pump already installed, actually beautifully installed, done really well, top notch. The homeowner had done it themselves, and it's still not pulling water, and they had neglected to realize that there was another issue. There's a ton of other issues it could be, but the easy way to tell is just to turn the pump off, open the lid, get a bucket of water or a hose, fill it up, and then turn the pump on with no lid on it. It's going to immediately suck that water out. As it's starting to suck the water out, try not to let it fill it up with continue to fill it up with the hose or the bucket, and the pump should just keep pulling. Any new water that you add to it, it should just keep pulling. And if it's pulling that new water, 99% of the time, your pump's totally fine. Do not replace your pump yet. I mean, you can if you want to, if it's an old pump and you just want to make sure that you're going to be good for the summer or whatever, totally fine. But plan on having other issues that you also need to resolve. If it's not pulling water, it could be the pump itself. It also could be something blocking the pump. Very common, a filter, dirty filter can block the pump. So make sure the filter is cleaned. If it's a DE filter, that powder has to go in relatively soon after it's cleaned. If you wait a couple days or a week with no DE and a DE filter, you're going to totally clog that up. So some ways you can rule the filter out is one, clean it. Two, you could pull it apart and run the system temporarily as a test without the filter. You could also open up the backwash valve and let that run as you're doing your pump test. You just don't want anything to block the pump. If the pump's getting blocked, the pump may be okay, but it may not be functioning properly. Okay, so for the electrical, you should have, most pumps will be 240 volts, so the wires, the power wires that are connected to them will be 2 hots and 1 ground. Read the manual. It'll tell you what your pump has, what your options are, and sometimes a pump will also have low voltage wire. So that data wire is RS-485 communication protocol, and that is basically a digital language that the pump will talk to its controller. And although they're all using when they are digitally controlled like that, and they're all using the RS-485, at least currently, they are speaking in a different way. So not all the pumps are compatible communication-wise with the controller, which we've talked about. When you are wiring the pump, on the pump side of things, it's usually pretty straightforward. When you get to the other end of the wire, how that wire is hooked up, the old way to do it is to have the pump controlled by a switch or a relay, which means that there is not power 24/7 to that pump. So the new pumps that have variable speed are designed to always have power to them 24/7 for the most part. Um, and they are then controlled digitally. So they'll digitally turn on or turn off, or higher speed or lower speed. But the powers, the high voltage is always there, ready to go, to take over the pump controls. So when you're wiring on the relay side, most of the time you're going to wire to the line side of the relay or to the line side of the timer. So you're kind of bypassing any of the other high voltage controls so that it's just on all the time. And then in the case where the controller is just on the pump itself and it's standalone, you don't need to integrate it to your app or to your automation system, then you're good to go. And then in the case where you do have some kind of pool automation, then you're going to get into the manual. It's going to talk about how to hook it up. It's going to give you like 3 different ways to do it. It's going to talk about the native way to do it, which is what you want to try for. That gives you your full capability for the pump. You'll need to, if you're doing it non-natively, then you'll need to evaluate those dry contacts and to read through the manual. It's not easy. Even if you call the factory and even if they help you, which they're reluctant to do because of liability, and even if you're experienced and even if you know what you're going on, it's still the way that they explain it can be sometimes take a lot of brain power and a lot of thought, and some prior experience and training in the area can definitely help. When all the electrical is hooked up, all the data communication is done, you want to run your bare copper wire at that point. It's very easy to forget. It's very common in the industry to forget to do that. That's a safety wire, and essentially if there's a power surge or an electrical storm or lightning strikes, it protects your equipment, and then it also becomes part of the grounding system so that all of your equipment can run to the grounding system of your entire house. So it runs back to the main electrical panel, which is designed to keep your house safe, and then it runs down into the ground to keep everyone else safe as well. So bare copper wire, the manual will tell you which. All right, so for the grounding wire, there's a lug on the outside of the pump. The manual will tell you what gauge you need of grounding wire. And then you're going to want to connect it to the lug side of the pump. Sometimes the grounding wire is already there, so if that's easy, it's long enough, you just hook it up. Sometimes if it's too short, it was on the other side of the pump, and this grounding lug's on the other side, so now you got to maybe run a little extra piece. Get an appropriate grounding lug so that you can connect the 2 grounding wires and then connect to your lug. The grounding wire of the pool should also be connected to the heater. It should be connected to the light box. It should be connected to the sub panel, and then it should go underground. And it goes underground actually to the swimming pool. And it's not obviously in the swimming pool, but it's around the entire outside of the swimming pool. There's a cage of electrical protection to pull anything away from the water, anything at all, that stray electricity. The goal is to pull that away from the water, pull that away from the equipment, push that all underground. So after that's done, it's time to check for leaks. Most pumps, you don't have to program it yet. We'll do that in a minute. Most pumps have some sort of manual override or cleaning setting so that you can just run it. And the idea is, hey, let's make sure there's no leaks. Let's make sure it's moving water. Let's make sure it's doing all those things that it should be doing. And then after you double check all of that, then it's time to program. So I usually recommend at least 3 things on a program for a pump: high speed, low speed, and cleaner speed. So high speed and low speed should be daily schedules. Every pool's different. The larger your pool, the more it should run. I typically recommend 3 hours on high speed and 10 to 12 hours on low speed. Low speed is typically 1700 to 2000 RPM. High speed is typically 3000 to 3400 RPM. Whatever is enough to move your cleaner. I have seen people experiment to try to get their speeds as low as possible, and while still having functionality of the pool, while still keeping the pool clean, just trying to minimize their electric bills. And that can work. It takes some patience and experimentation because you're just lowering the RPM, see, does it work? Wait a couple days, lower it again, does it work? The hotter it is, the more you need to run. The bigger your pool is, the more you need to run. The dirtier your pool is, the more you need to run. And so keep that in mind. I guess technically there is a way to buy a flow meter and observe how much flow you're getting, which actually changes based on how clean or dirty the filter is. But you can estimate it, and then you can say, okay, I want all of my water, the 20,000 gallon swimming pool, to run through my entire filter for the entire day. So if I'm running for 10 hours and I need to run 20,000 gallons in a 10-hour period, that means every hour I need to run 2,000 gallons, and every minute, you need to run you can start doing the math backwards and figure out how long you need to run the pool, at what speeds and at what RPMs, etc., to get the floors you want. Or you can just do it the practical way of, hey, rule of thumb is 10 hours on low speed, 3 hours high speed. Or you can get really involved with the practical way of testing your pool of, okay, I'm doing okay at 8 hours. Hey, my vacuum still runs at 2400 RPM, which is really rare actually, but let's say it does. Okay, great. Or hey, I need 28 at least. Or hey, 28's not cutting it, I need 3000. A lot of times I'll put it 3200 for a lot of my vacuums to run well and properly. So get those all dialed in. There is technical support numbers from the larger manufacturers. They'll help you program, especially if you have one of their automation systems and you're using the app. They'll help you program your pump. They won't really help you install it, but if they don't know you installed it, they will help you program it. And then the final thing I have to do after that, after you get all your programs set, is to protect the plumbing with UV paint. Excuse me. UV paint in the pool industry, pool paint typically comes in almond, Pentair almond, or Hayward gray. Jandy uses the Hayward gray as well as Hayward uses the Hayward gray. And it doesn't matter the color, just UV protection for your PVC. I'm sure you could probably get some kind of Rust-Oleum or something from Home Depot, but if I always use the pool paint colors because not only they match, but they're specifically formulated to protect the plumbing. So after you're done, let it dry, turn everything off, maybe 24 hours after you've tested it. Before you turn it on, don't blow your glue joints out. Some glue is rated to be able to withstand 40 psi after 10 minutes, which is the glue that I use, the Weldon glue brand. There is also, you just read the glue. Some glue wants you to wait 24 hours. So whatever that is, just follow that glue instruction so you don't blow your glue joints out. I would probably give your paint 24 hours, and that way if you have tiny drips somewhere, which is common, that you're not using those, it's not dripping over your new paint job or whatever. But congratulations, you just got a pump installed, and would love for you to call me if you need some help. If you think I could improve this instructions at all, I'd love some feedback on there. Shoot me a note, shoot me hate mail, just send me whatever you got, and I'd love to talk to you. Thank you. All right, so that's how you test your pump. If it's pulling water, you're good. And then, of course, if the pump is not the issue, you want to go identify what the issue is. So maybe your water level's low, maybe there's a leak in the plumbing valves, maybe they need to be resealed, maybe the valves are not set correctly, maybe there's an air leak in the plumbing itself, maybe there's a clog, etc. You can experiment by turning it to the spa, see if it will pull water from the spa or whatnot. Once we're kind of fairly sure that we're dealing with an actual pump issue, then we're going to move on to do some troubleshooting on that pump. So like, what is it doing? I've got, first we'll start with the issue of a single speed pump. One of the main issues of a single speed pump is that you're going to get like a buzzing sound, buzzing electrical sound. A lot of times that's the capacitor, not always, but a lot of times it is. Capacitors are cheap. Swapping that out, make sure you get the right size. They're measured in MFD, or sometimes you'll see a U with a little funny symbol and a UF. Both of those are symbols for microfarads. That's how capacitance or capacitors are rated. You're looking typically between 25 to 50. I think I've seen a 60 once in a while on a larger pump. But again, they're pretty cheap to get online. The exact size, physical size, doesn't matter as much as the rating of the MFD or the UF. So you can open up the back of the pump. There's a little compartment there. Sometimes you see a little bump on the top of the back of the pump. So that's an easy first step. If your pump's completely dead, like nothing's going on, you want to get your multimeter out. And again, don't mess with the electrical unless you are feeling very comfortable that you can keep yourself safe and you know how to keep yourself safe, and that you feel qualified to do so. So you can measure the amount of power that you have and compare that to what you're supposed to have. Almost every pump out there is going to be 240 volts. Occasionally it's a 120 volt system, and that's nominal, right? So if you're at 115 or 110, that's fine for 120, or if you're at 220 or 230, that's fine for a 240 volt system. And you want to make sure your pump's actually getting power. If you're not getting power, then you have a power issue. You got to fix that first before you can move on to the pump. And then sometimes what will happen is the pump will start up and then it'll run for just a little bit and then it'll trip a breaker. And so you're like, okay, what's going on? Is it wiring? Is it the pump? So what you'll do in that case is you'll disconnect the wires turn all the power off first, disconnect the wires from the back of the pump, and then make sure the wires aren't touching each other, because that will trip a breaker too. So separate those. And then as a test, turn the breaker on. You could probably cap them off to be safe as well. But as a test, turn the breaker on and leave it on for a little bit. And if it trips without the pump connected, then you know you have an electrical issue that needs to get resolved. If it doesn't trip, then you know you got a pump issue. A lot of times the motor shorts out, and so then the motor's toast. You can't use it anymore. And you got to get a new motor. Another thing that can happen is the pump's trying to rotate. It won't be exactly like that. Sometimes it is, but sometimes you'll hear like a, and it'll be trying to rotate, or it'll be stuck, and it won't be like as much of a clicking electrical sound, like it'll be a more smooth hum. Sometimes if the impeller is stuck or something is blocking it. So turn everything off, open up the pump, pull the basket out. If some pumps allow you to reach your hand inside and feel if there's anything going on with the impeller. Sometimes if the impeller's too far in, you can't reach your hand in there, you can get a pair of needle nose pliers, feel around in there and see if you can pull anything out. And sometimes that's what's going on. A lot of times pumps will have some kind of bolt or Allen connection on the very back in the center, and that's where you can actually rotate the motor by hand to feel if it's doing anything weird. It should be rotating freely, maybe, and if it's struggling or making sounds as you're manually rotating it, then you have either something stuck in there, or it could be also something going on with the motor. The motor itself could be toast. If you can tell there's debris in there, but you can't actually get to it, you can turn everything off and you can unbolt the motor from the back of the pump. That gets you into the inside where the impeller is. And you can remove the impeller. The impeller screw is going to be reverse threaded. That way when it spins around, it's not loosening itself. The impeller itself is also typically threaded on there. So you remove the screw opposite, so righty loosey, lefty tighty, and then the impeller itself you'd remove lefty-loosey and righty-tighty. Once you get that impeller off, you can start seeing if there's any debris in there. Sometimes you can see without taking it off that it's fine, or that there's a bunch of stuff that's stuck in there. It's amazing once you get that debris cleared out of there, how well the pump will work afterwards. Okay, let's see, what else are we covering here? Breaker trips. Okay, so then I guess the next thing would be, those are kind of universal. I guess the capacitor is only for single speed pumps. A pump will either have a capacitor or it's going to have a drive. A drive is for the newer variable speed pumps, which controls the pump and allows it to operate at different speeds. If that drive starts going bad on a variable speed pump, it's going to misfire and it's going to be controlling the pump in weird ways, and it's going to be moving too quickly. So it might accidentally tell the pump to run at 600 RPM and then tell it to run at 3000 RPM. And it's jumping so fast that the pump's not going to keep up, and it's going to automatically go into a fault mode. Sometimes it'll say it has a priming issue. Sometimes it'll say that it has an electrical issue, and in reality it just has a bad drive. You know if it's pulling the water. In our earlier tests, when you're done with the bucket, if it's pulling water, then you know the motor's okay. But if it's still giving you those issues and those errors, then that means your drive is going bad. Drives are expensive compared to replacing a pump, and it's also a little bit unknown. You don't know 100% for sure, even though the clues can point to a bad drive, you don't know 100% sure that that's the issue. It could very well be that your motor is bad and you won't know until you replace the drive. And if you do have to replace a drive and a motor together, you're almost like, why am I doing this? Let's get a new pump altogether. So that's how you tell if the drive's bad. So if you get through all of that and you're still having issues, it's time to replace. I guess refurbishment would also be an option. You could replace the pump completely or refurbish it. The repairs that we do on a pump, usually the pump's still working. So some people say, well, why do I have to replace it? Can I just repair it? Sometimes, yeah. So the parts that you can replace on a pump is the motor, the drive, or the capacitor, depending what it is. The seal plate, the diffuser, the impeller, and the shaft seal, and then of course all the gaskets and O-rings. So if your pump's pulling water, it's just leaking, you could definitely replace the internal components, shaft seals, impellers, diffusers, and kind of. I usually like to do the whole thing once the pump's open. You're not going to open it for a long time, hopefully again, and just get it all done. Typically though, the motor's moving if you're going to try to do a repair on the pump, kind of thing. So we got to the point where we've decided, hey, this thing's toast, which means you're going to either replace or refurbish. A refurbish is basically replacing the back end of the pump. There's third-party pumps that you can get that will attach to your front end. The front end, we call it the wet end. It has the lid and the basket. It connects to the plumbing. And the back end, we call it the dry end. There's plenty of those out there if you're trying to save some money. If you prefer just, hey, no headaches, let's get this thing done, you can buy a brand new pump. And so before we go and buy a new pump, or before we go either way, refurbish or replace a new motor or new pump, we want to make sure we understand what we currently have. I've seen plenty of times where people get stuck on excuse me, getting some water there. So that cleaner will also prepare the PVC surface so that it will be ready to accept the glue, and it kind of welds the glue, and the glue and the pipe almost all become the same piece as they get welded together. It's not officially welded, but it's chemically welded. It changes it chemically. As you're putting the plumbing together, you want to be as far as you can into the fitting, the plumbing to fit as far as it can in the fitting. I would say 2/3 I'm feeling really comfortable about. At half, I'm like, if I have to, I'll do it. Less than halfway into that fitting, I'm not going to do it. Not only not comfortable, I'm just not going to do that at all. So I would say 2/3 or more is best practice, and then halfway is acceptable on the borderline, and less than halfway, no way. A few more tricks when you're planning your plumbing to help you reduce the amount of work. The most amount of work that you would do installing a pump, and avoid this at all costs, is if you have to redo what we call the front manifold. Most pools, some pools have just one pipe coming in, so that's easy peasy. Most pools have three, one for the spa, one for the vacuum cleaner line, and one for the skimmer line. Even if you only have two coming in, you just don't want to mess with having to redo any valves or anything like that. So that means you're going to leave the valves in place. Those valves don't always match up with the height of the new pump. You can study that ahead of time too. If you want to get a pump, you can check the charts and the measurements and all that. Some pumps come with different stands so that you can raise them off the ground a little higher. I've seen some people use cinder blocks and a combination of tile pieces so that they can get it just perfectly to match up with where the plumbing's at. Um, to me, it looks cleaner if you don't have all that extra stuff under your pump. Um, and what you can do instead is use two 45s. So a 45 would come in, go down, and then another 45 would go the other way. So that would come down, and then it would pick it up and then go straight again. So you have a straight coming in here, goes to the two 45s, and then straight coming out this way. And you can rotate that to get at any height you want. You can match up any, so long as you have the space, physical space. You can get any size pump, whether it's taller or shorter than the current level of the valve, so you don't have to redo those. And then again, those 45s, very low friction, so that you can feel good about doing that. Another trick is sometimes the plumbing gets too close to the valve and you don't have enough pipe left over to actually make a connection, or the way you had to do a certain cut's not there anymore. The valves are designed, 99% of them are designed to be able to put a pipe inside of them, which usually is a 2-inch pipe for most plumbing, or you can put a fitting over top of them. So you could put a coupler right over top of the outside of the pipe. So if you run out of space outside of the valve, you can actually connect a 2.5-inch coupler to or other fitting to the outer side of the 2-inch valve, and then you can run a reducer, and that buys you more space and more options. Some other tips are to do the front first, do the back end second. The back end is easier to plumb because there's no valves involved. Some other tips would be to do the parts that you know have to be done. Sometimes there's some complication. You're planning out how the plumbing runs are going to work, and you're not sure, like, okay, I don't know how D and E is going to connect to each other. That's okay. I know I can do A first because it's non-directional. It doesn't matter. It can be rotated any way you want. So I'm going to start with A, and then I know that G is also non-directional, so I'll start with that. And so you can start building from both ends until you get to the point where you're like, okay, now I've got to get the direction just right. Sometimes if there's two fittings involved, they have to be at the right angle to each other to make the connections work properly. And that complication of the exact angle of those fittings can be helped by having other parts that are already there, and then you can use those to help guide you in the more complicated parts. Another thing that can be done is to try to make everything level. If everything's level, then when you're matching things up to each other, you know that they're all level, and so then you can make the conversions and the connections much easier. It doesn't absolutely have to be all level. It's just helpful if everything is. Makes things a little cleaner, a little easier on your connections. Um, a couple of other options if you just run out of options. The most fittings you should ever have to need to make a connection would be 4. And so essentially you get a 90 that goes up on one end, you get a 90 that goes up on another end. And pointing straight up for both of those, you can then run plumbing here and plumbing here. And then those two plumbings can have a 90 straight pipe and a 90. So you're essentially creating this U, and that's kind of a universal trick, so that that would be like your maximum. You're trying to minimize, trying to get less than 4 is the goal. Trying to get as few as possible, but in your mind, just make sure you know that's your worst case maximum number of plumbing that you need for one single connection. Let's see what else we've got. Something called that zero or self-aligning union. Sometimes either through bad planning or just sometimes it's just not possible whatsoever without having to cut a bunch of stuff out. You find yourself in a spot where you have plumbing that fits exactly and you have no space to push in one fitting, one plumbing into another, or one pipe into a fitting. And if you do push it in, then you ruin your other space. And so you end up needing to use what's called a self-aligning union. And so you can glue on both sides and they don't need to be pushed into each other. They just need to be threaded and sealed to each other that way. That does help in a pinch. Some other things that happen, sometimes we'll cut a pipe and water is just gushing out of it. And we're like, oh my gosh, we're going to have to wait like a day for all this water to come out, or we got to go drain a spa, or the pool has to drain out partially, or the plumbing is like 3 feet below the pool, which actually for regular operation is fantastic, but when you're working on it, it can complicate because gravity is taking over and is pushing out of the plumbing. You cannot glue wet plumbing. It has to be totally dry and clean. So a balloon with a string is actually really helpful in a pinch. There are special tools you can buy, like, couple $100 to plug stuff up while you're working on it and allow you to continue to working. But a balloon and a string can work wonders many times. Let's see. We're gonna also, when you're doing the glue, you can just push it. You want to be liberal with your glue. If you do too little glue, then you're gonna have some potential air that's seeping in there. That's the worst case scenario. Too much glue, you're gonna drip all over the place, which is not the end of the world. So I would always err on doing more glue than too little glue. Something else that helps, not always possible, but it helps, is once you make the connection between the plumbing and the fitting, you can rotate it just a little bit, maybe 1/8 of a turn, probably no more than 1/4 turn, and that helps to spread the glue a little better. Be careful on the ones that you cannot rotate, and there are connections where it just is not possible because you're making multiple connections or for other reasons. Be very liberal on those joints. Sandpaper can also help if you're feeling like, man, it's still kind of dirty, or I've used that strong clear cleaner solvent and it's not getting everything off. I want it to be cleaner. You can use some sandpaper. Drywall sanding paper works great, and really any kind of sandpaper, and just go around that pipe and get that cleaned up. If the paint's just not coming off existing paint on existing plumbing, and you've done everything reasonable to get it off, that's great. It's going to stay on there. It's going to become part of the plumbing. It's going to seal. It's going to hold pressure. You're going to be fine. You don't need to take it off if it's not coming off. And once the plumbing's done, then it's time to move on to the electrical. With the electrical, again, reminder, do not work on electrical if you are not 100% sure that you know how to keep yourself safe. And if you don't, do not work on it. And if you don't know what you're doing as far as why the electrical theory works, voltage differences, amperage, current, resistance, safety and following the code, please just don't do it. Get somebody to do it. I would be much happier with you hiring. Obviously, I want to be hired, but I'd be much happier with you being safe, hiring somebody else and who also knows what they're doing, than for you to take on something that you're not comfortable with. And that's not safe for you and your family. And maybe you end up being safe, but maybe the way the electrical is run is not safe. And I've seen some weird things, and it can be a problem. So let's make sure it's done right. All right, so now we decided, yes, we do want to replace and or refurbish the pump. So before we do that, we want to get all of the information pulled together. And as I was saying, I've ran into situations where people replace their own pump and afterwards something's not working. Hey, my vacuum's not working. Hey, the waterfall's not as strong as it used to be. Hey, the jets in the spa aren't powerful, kind of just weak. Like, what's going on? I cleaned the filter, checked all the other plumbing, everything's fine. And we found out, oh, you know what, your pump is not as strong as your last pump. Like, well, what do you mean? Because my last pump was 2 horsepower and my new pump is 2 horsepower. And what people forget to purchase off of is what's called total horsepower. So there's an important difference between listed horsepower and total horsepower. Many pumps have what's called a service factor, and the service factor multiplies the horsepower. So there's a lot of pumps, very, very common pumps out there, like an almond color, and they're listed at 2 horsepower with a service factor of 1.3. And so that means you multiply them. So 2 times 1.3 is 2.6. And so 2.6 would be the total horsepower. Some pumps are kind enough to actually list the total horsepower. Others don't. They just say 2 horsepower, 1.3 service factor, and they leave it up to you to determine, oh, that's actually a total horsepower of 2.6. So then if you go buy a pump that's a 2 horsepower motor, and it has a one service factor of 1, 2 times 1 is 2. So then you just took a 2.6 horsepower total horsepower motor or pump, and you just replace it with a 2 horsepower pump. So you've just effectively reduced your power by 25 or 30% or whatever. So that's sometimes enough to not run your pool equipment, your vacuum and your spa and everything else that you're used to having in there. So you definitely want all 3 of those: horsepower, service factor, total horsepower of your current system. You want to know what the voltage is. Occasionally there'll be a smaller pump that runs on 120 volt and your electrical wiring is not able to run 240 volts. Sometimes you end up having to run entire new power from the panel all the way to the pump if you get a pump that's 240 volts. Many pumps can be either or, 120 or 240. Some are only 240, some are only 120. So you want to know that going into it so you can select your options. The flow capacity of the pump. Sometimes this one's not as important. It can be if you're just totally trying to minimize how much horsepower you can get. The lower your horsepower, of course, the lower your electric bill, also the lower the functionality in the pool. So it's always a balance between performance and your electric bill. There are some brands, Jandy in particular, is very good at their flow capacity. So a lot of times, and this changes, so you need to look at the individual pump curves for the pump, but it changes in generations of pumps. A lot of times a particular pump can have a lower horsepower and a higher or equal to flow capacity or flow performance. And the flow capacity curves, as you look them up, will show based on the RPM and based on what they call total dynamic head, the THD, which is essentially, the simple way to think about that is the distance between the pump and the pool. It takes into account turns and filters and the size of the plumbing, etc. But essentially, you're going to see how much water a particular pump can move at a particular dynamic head at a particular speed or RPM. And that can, if you really want to get into the details, that can kind of guide you on if picking a lower horsepower pump is appropriate or possible. So we've checked out the voltage, horsepower, service factor, total horsepower, flow capacity, and now we want to talk about compatibility. It's the newer pumps, I call them smart pumps, and the older pumps, I call them dumb pumps. But essentially, the dumb pumps are simple. They're on and off, single speed. You hit them with power and they turn on. You remove the power and they turn off. So a simple time clock, mechanical timer, a simple relay in the automation system can fire it on or off, and something like that. With the smart pumps, they are interacting with either on their own, which is actually simple. A smart pump will have its own controller. And in that case, you don't have to worry about compatibility. But when you're connecting it to an existing automation system, that's when the compatibility starts mattering more. Generally speaking, there's a few exceptions, but generally speaking, you need to stay in the same brand family. So for Jandy, that would be Aqualink. Aqualink's capable of running Pentair pumps as well as Jandy pumps. There's some, and then with Pentair, they have the IntelliCenter, they have the Easy Touch, and they have the IntelliTouch. Those are the main, I guess there's a SunTouch as well. Those are the main automation systems for Pentair. So if you have one of those, generally, there's a few exceptions, you want to stick with a Pentair pump. And then, of course, if you have a Hayward controller, which those include OmniLogic, the OmniPL, the OmniHub, the ProLogic, Goldline, Aquatrol, and Aqualogic. They have quite a few different Hayward versions of their controller. You would want to go with a Hayward pump in that case. That being said, you also need to, it matters which revision of the automation system that they have. So there's some years that when you get back to a certain year of development, that the older automation systems, even though they have the same name like Aqualogic or Easy Touch, or even the Aqualink's just older versions, they will not run the new pumps. So then your options start getting a little bit more complicated. You have to start getting into, you either run it totally separate, so that's totally fine too. It could have its own control. It just won't, if you have a phone app, it won't be on that particular app. Sometimes you get a separate phone app for the pump, or you just manually control it on the back of the pump. The other options would be to start getting into some what they call dry contacts, and some pumps are capable of receiving just generic signals from the equipment, from the automation equipment. It will reduce the functionality of your options, your amount of level of control that you have of your pump if you care. Some people really get into that. Your configuration options. So keep that in mind as well. So it's a matter of checking manuals, checking in sometimes with the factory on compatibility, checking your revision of your current circuit board that you have, checking the brands and what brands are compatible of controlling the other which brands of pumps, and getting into all of that. So now you kind of have your entire knowledge that you need to be able to start selecting pumps, and it's easier to start eliminating pumps than to go through the sea of pumps and trying to start to pick one. So that's one way we can start eliminating it. If it's really important to you to have that control of everything all in the same system, then you know, okay, I've got to have the same brand, and then I've got to confirm that even within that brand family that it's going to work. And then you start asking yourself other questions. Hey, am I a zero headaches, best long-term reliability kind of person? If that's the case, then you want to go with a top brand pump, Jandy, Pentair, Hayward, and just replace the whole thing and be done with it. Don't try to refurbish it or repair it. Just set it and forget it. if you're looking at kind of, hey, I want something that is still energy efficient. I don't want something that's just a piece of junk. I want something that's decent. Then that's probably what we call like a mid-tier pump, and those would be like what's called a waterway. It would also be something made by U.S. Motors, which is used to be priorly owned by Emerson, and that would be the Neptune. There's also something called a V Green. Now the Neptune and the V Green would be motor replacements, not necessarily the entire pump, although you can replace the wet end as well, pretty affordably. Going that option. So V Green, Neptune, and the third one is Waterway. Waterway has another name called First Choice, same company, same exact pump. And those are kind of all considered your mid-tier pumps. And then there's kind of a lower tier pump, and I've installed all of these depending what the customer wanted. These lower tier pumps, you can kind of feel that they're not as strong. The plastic isn't as strong. They've always worked every time I've hooked them up and I walked away. They're moving water. The customer's happy their vacuum's working. They saved a few $100. But those two brands that I've seen in that category would be what's called Extreme, Xtreem, Extreme brand of pumps. And then there's also a Black & Decker pump. Home Depot usually has them on their website, 1, 2, and 3 horsepower pumps. So those are kind of all your choices. And then you got to decide, okay, am I going to DIY this thing, or am I going to go shop around for an installer? Don't forget about me if you are shopping for an installer. If you are DIYing it, then I'll kind of walk you through that a little bit. And then also when you're DIYing it, just keep in mind the warranties are not as good for DIYers, and unfortunately, the manufacturers, maybe they shouldn't, but they do. They give more trust to a professional installer, that they're going to have a lower likelihood of having issues and having to warranty things. And so the warranties the installers get is typically between 1 to 3 years. Usually on the 3-year end, the higher the quality and higher brand of pump will be more skewed towards the 3-year warranty. The online warranties typically aren't as good. They're typically like 30 to 90 days. And so those don't last you very long at all. It's basically enough to see if the thing turns on. And that's basically all you get. The installer warranties will come with labor and the pump warranty, not only from the company, from the installer, but it'll also come with a labor warranty from the manufacturer. So if something happens to your installer, they move, or they're not doing pools anymore or something like that, then you still have that warranty through the manufacturer. So save your invoice with the date on it, showing that the date that it was purchased. They go off of purchase date, installation date, rather than off of the manufacturer date. They will default to the manufacturer date, but that doesn't help you if they manufactured it 4 years ago and your installer installed it 2 years and 9 months ago. That would still be under the 3-year warranty if you have the documentation. If you don't, they'll go off the manufacturer date because that's all they have, and that'll show a 4-year time window, which would show that it's out of warranty. As far as getting into the install, the first thing to do is kind of plan it out, get everything pulled together so you have everything all at once. It's going to take you a long time anyway on your first go. Generally, a pro can do an install between 1 to 4 hours, depending on the complexity of the job. Novice, you might be at an 8-hour install. So just be ready to get the work done. And maybe you've got some skills and experience, and you maybe can go faster than that. But just be ready to spend some time, and maybe be ready to not have what you need, have to order stuff, etc. So first thing is safety. Safety always first. Eye protection, latex or some kind of equivalent gloves to protect yourself from the glue and solvents that will be getting used. I like to put mechanics gloves over, which are like a half neoprene glove, over top of my latex gloves. That gives my hands protection as well as from just the physical work. Um, Ear protection for when you're running that Sawzall, a ventilator mask for the glue that you're going to be using. Um, I never felt like I got high, but man, those fumes can be really strong. So definitely a ventilator mask is helpful. Protective clothing, and then of course protective footwear. Plumbing tools that you're gonna most likely need would be like a large 16-inch or maybe even larger channel lock, the Sawzall to cut the plumbing, glue and primer. It's very helpful to have a level and a square as well as you're working. Um, Plumbing materials that you'll most likely need, it's all PVC. The pool plumbing, you'll have to see what you have. 1.5 inch, 2 inch, 2.5 inch, or 3 inch is all the ranges that I've seen for residential pool plumbing. Um, and then you're gonna wanna, as you plan it out, you're gonna wanna have on hand couplers, reducers, 45s, sweep 90s, street sweep 90s, standard 90s, street standard 90s. There's something called an extender that really helps, especially if you make a mistake or you don't have any other options. It fits inside of the pipe, gives you a little more room in a pinch. I try not to use them at all possible because it chokes out some of your plumbing efficiency. And then there's unions that go on the pump. There's sometimes what's called a self-aligning straight union, which would be just for a straight pipe if you run into a tight spot. Check valves and diverter valves. Want to be ready with all those. For your electrical, you're going to need screwdrivers, wire strippers, cutters, multimeter. Electrical supplies, everything's 1/2 inch. I guess there's a connection where you need a conversion, but that's pretty rare. Almost everything's always 1/2 inch. So 1/2 inch connectors. You need a whip. Sometimes they'll sell like a 6-foot whip. It's got 1/2 inch Liquatite conduit, and inside of it, it's got 2 hots, 2 reds and a green. That's a 3-wire one. You could get a 4-wire one sometimes. If Actually 3 wires is probably all you need, because if you got a 120-volt system, then 1 hot, 1 neutral, 1 ground. If you got a 240 volts, you have two hots and 1 ground. And then sometimes you need some grounding lugs and some bare copper grounding wire. And then before you start this project, just honestly evaluate your safety level, your comfort level. Hey, do I know I can keep myself safe? I'm going to be messing with 240 volts in the electrical panel, turning the breakers off, turning them back on. I'm going to be using a Sawzall or a handsaw, which can introduce some risk. I'm going to be using some glue, which has some risk with the fumes and whatnot, and there is ways to keep yourself safe doing all of that. You just want to ask yourself, am I willing to do it, and do I have the knowledge and skills, or am I willing to get the knowledge and skills to be safe? So reading all the instructions, reading from the manufacturers, researching safety protocols, and being ready safety wise to do this job. Next up is to remove the old pump. So you're going to turn off all the breakers and follow all those safety guidelines. You're going to remove the pump unions if there are any that simply screw off. If there's no unions, you're going to cut the plumbing. You want to cut right as close or right on top of, right next to the pump. You're going to preserve as much of the existing plumbing as possible. That will give you the most options when you're dropping your new pump in. Sometimes you need that plumbing in place. Sometimes it's not replaceable. After you cut it, you have to go cut further back, further up the line, and then you end up replacing a bunch of stuff that you could have avoided. And then after that, so you're going to disconnect the electrical. So the easy one's a bare copper wire. It's usually on a lug. Well, supposed to be on a lug to the pump. I see a ton of those where they're not even connected up. So you can cut that really close to the pump, or you can unscrew it if it will unscrew. Sometimes it's really corroded and won't come off. And then you want to remove the electrical connection. I prefer to try to, if possible, if it's in good good shape to try to reuse the electrical conduit. Those things last decades and decades. If they're in good shape, you can keep using them. And so that you want to disconnect and preserve as much of that wire as you can. There's a compartment either on the back rear of the pump or near the rear of the pump where you can access the electrical components. Unscrew the wires, unscrew the connector, slide the conduit out. If the connector is still good, you can spin that off and reuse that for your new pump. Pull the old pump out of there. Sometimes it's really heavy, full of water. Dump the water out. Sometimes there's a spaghetti bowl of plumbing everywhere, and you actually have to be strategic and maneuver that pump carefully out. Pretty rare I have put too much pressure on a pipe that I sat on as I was removing a pump from a spaghetti bowl and I broke up some plumbing. So be prepared to redo some plumbing if you need to. Not a big deal if you know what you're doing. And then just be careful to try to avoid causing yourself any extra work that you need. After the old pump is pulled out of there, you want to clean up everything. You want to get it, if you got a yard broom or a pool brush or something, get all the dirt out of there. Get the platform ready to put the new pump in. Let's see. All right, so coming up next, we're gonna try to be strategic. What we're trying to do is minimize how much work needs to be done. And also we're trying to minimize how much friction we're putting on the plumbing. So if I don't know what I'm doing, then I'm running a whole bunch of extra turns, extra 90s, kind of be all over the place and look really weird. You want the plumbing to be clean, not only because it looks better, but also you want it to be clean in the sense that it's not going to add extra pressure to the system. It's not going to cause the pump to have to work harder to move water through the system. It's not going to cause more vibrations, more maintenance on your pump, a higher electric bill. You just want to try to get it to be clean. So friction equals energy equals slower water equals more strain on the pump equals more pressure on the whole system. So the lowest friction options in order would be a straight pipe, very low friction, and the bigger of the pipe, of course, the lower the friction. So the biggest pipe you can use, the straightest you can be on the plumbing. You need 45s. 45s would be the next least amount of friction, and 245s would be better than a 90. You get lots of space to move through that pipe. After the 45 and the 245s, the next lowest amount of friction would be called a sweep 90, street sweep or sweep 90. And those are nice smooth corners that the plumbing, the water can move through. It's 5 times different. So the sweep 90s are 1/5 the amount of friction from the standard 90s. And then, of course, after using the sweep and street sweep 90s, then you're into your standard and street 90s. Those start adding a lot of friction. Sometimes they're needed. We minimize those to hopefully 0 or very, very low number of those standard 90s. And then some other tips and principles to use is that when gluing the PVC, you don't want to just use glue. You want that connection between the PVC and the fittings to be very clean, very strong, very waterproof. You want to be able to resist and hold pressure. And so one way to do that is with a cleaning solvent. We call it a cleaner. And that can clean. Sometimes it'll eat off paint. It'll eat off, like the plumbing has those black markings that say PVC and 2-inch and whatever standards they use, 40 for Schedule 40. The cleaner solvent will actually clean that off, and then it also prepares the PVC surface